exponential, so they are gonna have the standard form, which is y equals a times b to the x power, okay? But they change the b, okay? Depending your growth rate, depending on if it's increasing or decreasing. So your a is still the initial amount, okay? That does not change. B as a growth factor, when b is greater than 1, okay, we now change the b that we have here with this expression, this parentheses, 1 plus r. This basically represents the b. So we rewrite b as 1 plus r. So I'm just going to underline the key information. This is the formula for growth, exponential growth. So I'm just going to highlight this. When I'm talking about growth, it's going to be 1 plus r inside the parentheses to the x power. The part we have to know is that the growth, the growth rate right here, that is your r. And that r is usually a percentage written as a decimal. Okay? So when I look at this example, the example is right here. Y equals 2 times parentheses 1.43 raised to the power of x. Okay? They want to know the growth factor. The factor would be the b, guys. So what part in this equation represents the b? Yeah, the b is everything inside the parentheses. So the growth factor is 1.43. Remember, the growth rate is the r. Okay? The r right here, the 1 plus it, right? 1 plus the rate. So if I have 1.43 inside the parentheses, what would be the r? Yeah, the 0.43. Remember, because we're adding 1 to it, and right there, there's 1 plus, or 1.43. So what's inside the parentheses has already been added to the rate. Okay, the 1 has already been added to the rate. So if I want to find the rate, just subtract it by 1. All right, now, what would be the initial value?
2.
The 2. Whatever's in front of the parentheses, that's your a. Remember, initial value is the a of the exponential function. And so that would be our initial value. Okay, so what you're going to do today, probably finish tomorrow, is that we're going to now have you graph these type of functions. The first thing we want to make sure you can do is know the difference between a growth and a decay, and then complete a table and complete a graph. So if it's plus, that's growth. If you look over here, okay, everything here is staying the same. We're going to have a is the initial amount, b, when b is between 1 and 0, okay, that would be a decay factor. So the difference between right here, instead of being 1 plus r, I'm doing 1 minus r. So for decay, and I'm going to make this blue, we're subtracting. For growth, we're adding. Okay. So b is now your 1 minus r would be your b. R is still, or the r, when it's subtraction, r is your decay rate. R doesn't really change. It's usually a percentage, and it's always written as a decimal. Okay. You just got to pay attention to that middle, what's inside the parentheses. If I see a value less than 1, then I should automatically know I'm dealing with a decay. When I see values greater than 1, then it's a growth. Okay. This is my decay. Oops. Talking about decay. All right, so if I look at this example, for example 4, this is a function or the equation they gave you. Y equals 300 times 0.75 to the x power. So what would be the decay factor?
0.75.
Yeah. Where's my pen? Keep it the same. All right. All right, so our decay factors are 0.75. What is the decay rate? Remember, we're thinking about the R.
0.75.
Mm-mm. This is in here, right? What would the rate have to, what would the R have to be to get 0.75? 0.25. Just subtract one. If you just can't get a habit of always subtracting one, you'll get your rate. And then also, yeah, what's our initial value going to be? Yeah, 300. Okay. All right, so the way we're going to start off with using exponential functions is I'm just going to give you the equation. You're going to look at the equation, tell me if it's a growth or a rate, or a decay, excuse me. And then you're going to fill in the table. You're going to sketch a graph. You're going to tell me what the growth factor is, the growth rate. You're going to tell me the parts, okay? So in example 6, based on this equation, would this be a growth or a decay? Yes, it is a growth because 1.5 is greater than 1. You have to pay attention to your parentheses. What's inside the parentheses determine growth or decay. All right, so what I want, and even on the worksheet, guys, your table is pretty much going to be a -2 to a +2. So we got -2, -1, 0. Actually, this is going to go to 3. 1, 2, then 3. All right, I want you to use a graphing calculator to fill in the table. Okay? I want us to use a graphing calculator to fill in the table. So I don't think I have my calculator on today yet. Yeah, use your parentheses. Type it exactly like it's written. Yes, sir.
It's okay with
Yeah, that's fine. So we go y equals 2 parentheses 1.5 close the parentheses raised to a power of x. We store that, yes, and go to your table. We need our table to start at a -2 though. So go up, all right, to fill in our table. Okay, so when we fill in at a -2, we had, what was it, 0.8 repeating. Yeah, and then at -1, we had, was it 1.3? Let me change my font. 1.3, okay, repeating. And then at 0, we should have had 2. Yeah, that's the initial value. And then at 1 is 3, 2 is 4.5, and 3 was 6.75. All right, so we're going to sketch that on the graph. So -2, 0.8 is close to that 1. At -1's 1 1/3, so close to the above the 1. 0, 2, 1, 3, 2, 4.5. Here's 4. Here's 4.5, and then 3, 6.75. So it should be curving like such. Are we okay? All right, so they want us to identify what was our growth factor. Where is that located? Inside the parentheses. So it is our 1.5. Are we okay on that part? What would be our growth rate? 0.5, yes. And then what's our initial value? Yep, 2. It's the value in front of the parentheses. We kind of got the hang of this, what we're doing here? Everything will, for this first part, will be calculator based. So you have to fill in the table, have to plot the points on your graph, and then answer your questions based off your equation or graph. All right, so if you look at example 6, because our equation right here is y equals 2 times 1/3 to the x power, is this a growth or a decay? It's a decay. 1/3 is less than 1. Okay, so if they give you a fraction and that fraction is less than 1, it's going to be a decay. So I want us to, let me see, should I change it so it's whole number answers? Yeah, it works. There's a fractions at the end. That's fine. Okay, do the same value. Sorry, let me fix this. Do the same table. Okay, I'm gonna leave this here. My arm. We're going to do -2, -1, 0, 1, 2, 3. Okay. If you put the fraction, if you use a fraction in your y equals, I'm going to go with y'all, you will get fraction answers. So if you do 2 parentheses, but then alpha y to make the fraction box, and type in the 1/3, close the parentheses, raise it to the x power. Okay, you have to use, yeah, you would get the fraction result when you use fraction into the equation. If you do 1 divided by 3, you'll get decimal answers, yeah. So when I go to second graph, see, I'm going to have fraction results. If I do, I'll put it on the y2. If I type the same thing and I do 1 divided by 3, which is the same, guys, it's still correct. Okay, it's just one is just showing the fraction result and one's doing the decimal. So when I do second graph, see, now that's just giving me the decimal answer. No, it doesn't really matter. You just got to make sure. Sometimes if they give you a graph with the fraction, you just got to remember, okay, I got to remember what fraction that is. It's usually going to be equivalent to what you have in your table. Okay, so let's fill in our table. I'm going to go red. All right, so at -2 is at 18. -1 is 6. 0 is at 2. Then 2/3, 2/9, and 2/27. Ooh, that's real small. Okay. All right, so -2, there's 10. So 18, y'all know that's going to have to be off the graph, right? Yeah, -1 is at 6. 0 is at 2. 1 is at 2/3. That's kind of, they're closer to 1. 2 is at 2/9. That's going to be closer to 0. And then closer. So like, it's like, oops. Curving, decreasing from left to right, and getting closer and closer to the x-axis. Like that. All right, what's our decay factor? What would be our decay factor in this equation? Guys, it's always what's inside the parentheses. When I'm talking about factor, it's what's inside the parentheses. So what's our decay factor? 1/3. Okay. Our decay rate, 2/3. And our initial value, 2. Okay. All right, so on that worksheet that you had, that we started off with, flip it over. Okay. All right, so couple things, guys, I need you to make sure you do. The first 3 is just telling me, would it be a growth or decay? Just looking at the equation, okay? But for your graphing and identifying the key facts, you need to make sure you do a table with x and y values, always using a -2 to a +2. Okay? That's how you're going to be able to graph it. So every single graph For this worksheet, you need to create a table and just use your calculator. Now, I know some of you might not have access to this calculator at home. I will talk about an option of, if you have an Android phone, it's a free app. You can do the TI 84 for free. Okay. If it's not, if you have a PC, there is an option to put that on your computer. And I just have to give you the video explanation on how to do that. If you want to have access to this, I would, guys, if y'all are planning to, continue, take the PSAT, the SAT, maybe take an upper level course or college algebra, maybe before you graduate to get some college credit. If you're planning to take, every college student has to take college algebra, okay, no matter what your major is, okay? So most classes, this is a requirement to have one of these calculators, either a TI-84, an Inspire. They hardly use Casios anymore. So, you're just going to have access to a graphing calculator. And might as well just invest in the one that you're going to have to use for the next probably 4 years, okay? All right, so for this, you're going to put the equation in the calculator. I'm going to clear this out. Our equation that we have was 1/2. Make sure I'm looking at it. Yeah, 1/2 to the x power. So you can use your parentheses. You can use your fraction box if you want to, or you can just say 1 divided by 2. Either way. Just make sure you're using parentheses and you're raising it to a power x. And then you're going to fill in your table based on those values, graph the table based on those values, and then answer questions, okay? So right off the bat, would this be growth or decay? Yeah, so we're going to circle decay. Then because it's an exponential function, what is the domain always? All exponential functions have the same domain. You can say infinity to infinity, or you can say all real numbers. That's the symbol for all real numbers. It's like a double R, a double bracket R, okay? Okay, your range depends on your graph. So that's different. You can be able to read the y-intercept off your graph, and you should be able to read the asymptote off your graph. So if I went straight to graphing the actual equation, this is decaying. Does the graph ever pass the x-axis?
No.
So that lets me know my asymptote. My asymptote is y = 0. That is the x-axis. And my range would be y is greater than or greater than 0. Okay, because it's always above the x-axis. So you gotta just basically go based off the asymptote. We'll talk about that. So I do want you to work on this. If you don't have a calculator at home, then worry about the back in class on Monday. Does everyone understand what we're doing here? This will be a grade. I am going to check it. All right, let's go ahead and pack up.